Today we're going to do lesson 10 and 8 in 1. This is operations in scientific notation. We are going to focus today on three kind of key sections. The first one is multiplying and dividing numbers in scientific notation. This can totally be done using the building blocks that we've discovered and developed in 7th grade, and then again in which is commutative property of multiplication. And we're going to also use our building blocks, knowing what we know about multiplying powers. Then we're going to jump into a couple word problems, one specifically from today's lesson, and then we're going to move on over and do one problem that will give you a good indication of some help on one of the problems from the problem set from lesson 10. So let's get going. Whoa, let's go. All right, let's do it. Here we go. Moving on over. Okay, so we're going to learn, multiplying and dividing numbers in scientific notation. Let's start with multiplying numbers in scientific notation. So we're dealing with, a number written in scientific notation, remember, looks something like this. So if we take 2.0 times 10 to the fourth, and we want to multiply that number by another number in scientific notation. Watch how cool this is, and then we'll come up with the rule. We'll just do a little bit of magic. So we're multiplying this number times this number. Well, notice that we can use and I already gave you the hint, and we're going to use the commutative property of multiplication, and we're just going to rearrange this. And watch what we do. We're gonna put these two numbers together, and then we're gonna put these two numbers together. Because look, a number written in scientific notation is just two numbers multiplied together. And then if we multiply it by another number in scientific notation, which is just two more numbers multiplied together, we effectively have four numbers multiplied together. So watch what we can do. We can take that first one times that second one, or times the third one, and then we can take that third and that second one and that fourth one and put them at the end. And now we can use regular multiplication to simplify. So 3 times 2 is simply 6. And 10 to the fourth times 10 to the second is 10 to the sixth power. So notice, all we've done when you multiply numbers in scientific notation is you multiply this is the rule. You multiply the numbers, the first two numbers, right? So 2 times 3, that gives me my 6. And then B, we add our exponents. Right? So 4 plus 2 equals our 6. Okay, so that's the whole key. So let's do another one. I'll let you do it. 4.0 times 10 to the 10th times, that's one number, times 1.5 times 10 to the negative 2. So you should pause and try. Pause and try. Okay. Well, what do? We multiply the first two numbers. We say 4 times 1.5, and that equals 6. And if you need to work that out on paper, you can. And then we say, well, 10 plus negative 2, 10 to the 10th times 10 to the negative 2 is equal to 10 to the 8th. So our answer is 6.0 times 10 to the 8th. Okay, so that should be a little bit of review for what you learned in class today, but that's our key to multiplying. Now there's one last key piece, is sometimes you have to remember, you have to move to scientific notation, because watch what happens. And this is only sometimes. Because if you take this is problem, so that's problem B. Now problem C looks like this: 5.0 times 10 to the 4th times 7.0 times 10 to the, we'll do this one to the 4th also. Now that's going to equal, watch what happens. If I take 5 times 7, I get 35.0 times 10 to the 8th, right? Add exponents, multiply the beginning numbers. But this number is not in scientific notation. This is not scientific notation. So sometimes you multiply two numbers and you get a number that are in scientific notation, and you get one that's not. Well, we can move this into scientific notation by using a trick that we learned in lesson 8 and lesson 9. We take that first number and put it in scientific notation, right? So watch. So that's 3.5 times 10 to the 1st. And if you forgot how to do that, if you forgot how to take this number and put it into scientific notation, go back and recall that in lesson 8 and 9. And that's times 10 to the 8th. And so now we can combine these two numbers and we can get 10 to the 9th. And that number is in scientific notation because 3.5 is between 1 and 10, and then 10 to the 9th is is a power of 10 with an integer exponent. So for 35 times 10 to the 8th is the same thing as 3.5 times 10 to the 9th, but 3.5 times 10 to the 9th is in scientific notation. Okay, so let's move along and let's go to another problem, which is division. And we're going to use the same kind of principles when we do our division. And we're going to divide division, and we're going to find our rules, which are, we'll have an A, a B, and a C over here. So when we divide, we say 9.0 times 10 to the 7th divided by 3.0, and I'm using numbers that work out kind of nicely, but the same rules will apply. And so the way that we look at this one is we say, well, let's write this like a fraction, and it will become more clear what we need to do. And I'm just going to use a few tricks here, and then we're going to come up with our rules. So we can write a division problem like that, right? If we divide these two fractions, let me be more clear with the parentheses. 9.0 times 10 to the 7th divided by 3.0 times 10 to the 4th is the same thing. Watch what I do here. That's the same thing as this. Nine over 3 times 10 to the 7th over 10 to the 4th. And why is that? You can convince yourself that that's the same because it's easy to go from here to here, from all of this to that. And so just like we can, basically what we're saying is A times B over C times D. It's the same thing as A over C times B over D. And those rules we learned in 7th grade. So you can just stare at that for a little bit and convince yourself that that's true. But that's not, again, these are building blocks that you need to internalize to help understand how these rules that we're going to build apply, and how and why they're true. But once you get to here, things get really easy. So watch, 9 divided by 3 is just 3, and 10 to the 7th over 10 to the 4th is 10 to the 3rd, and that's by our quotient rule of powers. Right, so our answer here is 3 times 10 to the 3. And what's the rule here? So when we multiplied the first two numbers, and then we added the exponents. So in division, we do kind of the handshake, or the opposite, is we divide first numbers. 9 divided by 3, and then we subtract exponents. Okay, so let me go one step further here. So sometimes, and in C, sometimes we're gonna have to convert to scientific notation. This is the same as multiplication, and I'll show you how that works. So let's look at another example here. And so let's look at a number where we do 1.0 times 10 to the 5th divided by 2.0 times 10 to the 1st. So we do our rule. We divide, the first number is 1.0 over 2.0, and the second part is 10 to the 5th over 10 to the 1st. So we divide our first two numbers, and if you divide 1 divided by 2, you get 0.5. And you can do that out longhand, right? But I'm not going to do that for you here. But 1 divided by 2 is 1/2, which is 0.5. And then that's times 10 to the 4th. Do we have a problem? Are we in scientific notation? The answer is not. We are no. We are not in scientific notation. So we have to put this into scientific notation, and again, building blocks, lesson 8, if you forget how to do it, but this is the same thing as 5 times 10 to the negative 1 times 10 to the 4th. And now we do the same trick as we did with the multiplication, and we combine these, and we end up with 5, and I'll call it 5.0, which is the same as 5, times 10 to the 3rd. And there's our answer. So again, this is optional. This C, or not optional, but it's something that we have to do if our answer after doing A and B is not in scientific notation. This is the thing that we have to do to convert from our answer into scientific notation. Okay, so we know how to multiply and divide in scientific notation now. And so let's do a problem. Let's do a couple problems. The first is from the chapter, and so let me pull that up. And that's the mass of the moon is about 7.3 times 10 to the 22nd, and it would take approximately 26 million moons to equal the mass of the sun. So let's think about this. So we have a moon here, and I'm going to draw a few of these moons. And we need to have a whole bunch of these moons before we equal one sun. So this big thing is the sun, and each of these little things are moons. And we need to have 26 million of these things. Boom, 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 boom. I can't even get, that's probably 100. I need 26 million moons to equal a sun. So what's bigger, the moon or the sun? Well, the moon is a lot smaller because it takes 26 million to make a sun. So we need to say, is this a multiplication or a division, addition, or what kind of problem is this? Well, the answer is this is a multiplication problem. We need to multiply our moon size we need to multiply that thing 26 million times. We need 1, 2, 3, 4, 5, 6, 7, 8, 9, 26 million of these things. So the way we're going to do this and do this a little easier is we're going to use scientific notation. So we're going to convert this guy into scientific notation. Well, that's 2.6, I know, times 10 to the what? Well, we can use our rule here, our 1, 2, 3, 4, 5, 6, 7, 10 to the 7th. The other way we can do it is we can say, well, what number is just under, what power of 10 is just under 26 million? And that's this, and that has 7 zeros. Okay, and so there's our 7. So either way you want to do it by moving decimals or by finding the power of 10 just below it, either one will work. And so we need 7.3 times 10 to the 22nd. And so now we can figure out what the mass of the sun is. It's 2.6 million moons. So we know how to do the second part. We know this is going to be 10 to the 29th. And now we have to multiply 2.6 times 7.3. Well, when you work that out, it turns out that the answer is 18.98. Right? We multiplied these numbers and we added our exponents. Now, the problem, does anyone see the problem? Yes, the problem is that this is not in scientific notation because this number is too big. So we need to now put that number in scientific notation. And then pull down our second part. And we get an answer of 1.898 times 10 to the 1 plus 29 to 30th kilograms. And there we go. That is the mass of the sun. Good. Okay, let's do a different one. And let's do one where we find the, this will be a different kind of problem. And I think you'll figure it out quickly, but in this case, we know I'm going to give you some numbers. I'm going to say Mars is 6.4 times 10 to the 24th kilograms, the unit of mass. And I'm going to tell you the sun now is, we just figured it out, but I'm going to round it and say the sun is 1.9 times 10 to the 30th kilograms. So here we have a situation where we have, again, the sun, and then we have a bunch of little Marses. And each one of these Marses is 6.4 times 10 to the 24th kilograms. So the question is how many Marses add, or not add, make up one sun in weight, in mass. So if the sun is giant and it's 1.9 times 10 to the 30th, is this a multiplication problem or a division problem? Right? If I have 30 pounds of balls, and then each ball weighs 3 pounds, each ball weighs 3 pounds, and the whole thing weighs 30 pounds, this is how many balls do I have? It's a division problem, right? 30 divided by 3 equals 10. Right? Similarly, if I have a whole bunch of Marses that weigh 6.4 times 10 to the 24th kilograms, and the sun is 1.9 times 10 to the 30th. This is a division problem. And so remember our steps for division. Now we got to go back to the procedural problem. We've done the critical thinking. Now we just got to calculate this guy. And so we break it up into pieces. Remember, we're going to divide that, and we're going to subtract exponents here. So we got to figure out what 1.9 divided by 6.4 is. And if you work out that division, this is 0.2. Well, it rounds to 0.30. You get something like 0.2968. But if you round that to 2 digits, you get 0.30 times 10 to the 6th. 30 minus 24 is 6. But again, the problem here is this is not an X in scientific notation, so we have to convert this into scientific notation. And then we get 3 times 10 to the 5th Marses in one sun. And that's a lot. That's 3 with 5 zeros after 2. It'll take 300,000 Marses stacked together to equal the mass of one sun. That is one big sun. Okay, final problem. We're going to do a question that will help you perhaps with this is problem set help or homework help. Okay. It's in green. So here's the question. Light goes 1.9 times 10 to the 5th miles per second. Every second it goes 1, 2, 3, 4, 5. 109. It's actually 186,000, but we rounded. 186,000 miles every second. So the Earth is just 25,000 miles around. So this is 7 times. In 1 second, light can go 7 times around the Earth in 1 second. So the question here, light travels. So how far does light travel in 1 hour? And remember, there's 3,600 seconds in an hour. There's 60 seconds in a minute and 60 more minutes in an hour. So 3,600 seconds in an hour. So if light goes 1.9 times 10 to the 5th miles in a second, in 2 seconds, it'll go 2 times that. In 3 seconds, it'll go 3 times that far. In 4 seconds, it'll go 4 times that far. And in 3,600 seconds, it'll go 3,600 times that far. So we're going to do this multiplication in scientific notation. So to do that, both numbers have to be in scientific notation. So let's put this one in scientific notation, right? 1, 2, 3. 3.6 times 10 to the 3rd. 1.9 times 10 to the 5th miles per second times that. So let's do our power of 10 first, which is going to be 8. 5 plus 3. And then we have to multiply 1.9 times 3.6. 1.9 times 3.6, and that equals 6.84. miles. And are we done? Yes, we are done, because this is in scientific notation. So sometimes when you do your multiplication, you end up with a very nice number that is in scientific notation. So we can be done, but let's just figure out, you know, that's how far that is. That's 684,000,000,000. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Wow. In 1 hour, light goes 684 million miles in just an hour. That's a long way. If you started running right now, I don't know, probably it would take you many lifetimes to get there, I would estimate. Okay, so we are done with today's lesson. I hope that was useful for you. We learned how to multiply and divide numbers in scientific notation. We did a few examples where we had to multiply and divide. We had to use a little critical thinking to set up our problems. We did a sample problem that will be like one of the homework problems, and we will keep moving forward with scientific notation. Hopefully this is useful. Let me know. Thumbs up on YouTube if you're digging this. And otherwise, I'll see you next time. You are welcome.